Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Uh, Today, I was going to show you another simulation um, that, would I wanted through it to show you some capabilities of RStudio, or how can we use RStudio for other problems that would be similar, or you can model it the way we are going to model this simulation. This simulation is about Brownian motion. You heard this term before. Many of you know about it more than I do. So basically, what we are going to assume here is that we have a square area, let's say of size 20 by 20 units. Okay, so let's say this is -10, this is +10 along the x, and -10 to +10 along the y. And in the middle, at the origin, there is a particle at 0 and 0. Okay, and this particle is capable of moving in any direction, but the x component of that motion of every step cannot exceed 1, and likewise in the y. So, for example, I can move 1/2 to the right and 1 up. I can have from here, I can move, say, 0.7 to the left and 0.2 down, and I keep moving like that. Okay, like so in any direction until eventually this particle, let's say it's going to go out here. Once it goes out, I will stop the simulation, show the trajectory on the screen, and count how many steps it took it. So let's say a step happens every second. So how many seconds until this particle will go outside this area? Okay? It's not that interesting, right? It's like you are just looking at something random happening, but we can use something similar to that in other applications. That's the key word, modeling. Meaning when you are encountered with a new problem, you have to have um, like a lot of experience looking at different cases. And then you say, oh, I think this one looks like a problem I did when I was, say, in high school or in college. And now let me model it the same way we did and then solve that. Okay? So the idea is not about this, but how to create a simulation like that, how to plot it on the screen, and how to get specific information from it. Maybe I will introduce new stuff that we haven't done before with RStudio. So bear with me. I hope you like it. Here is RStudio. As usual, I'm going to clear the environment. And then I'm going to say, well, all what I need to do is to say, I'm going to create a matrix. I don't know how many steps it's going to take. I have no clue. Would it take 5 steps? Of course, cannot be 5 since the width is 10. So would it take 20? Would it take 100? Would it take 200? I have no clue. So let's create one. We know that we have a lot of memory. It's not a big deal like the old days. So maybe I am going to create a new matrix, call it new math for matrix, and I say this matrix is a matrix. I'm going to fill it up with 0 or empty, so I can say NA with, we haven't yet decided N. So let's say N and 2, but then before that I have to say, what do I mean by N, right? So let's say N equals 1,000. I don't expect it to be higher than 1,000 steps, right? So we can even make it 10,000. It doesn't matter, right? So once this is the basics, and then I'm going to say, here I'm going to encounter a small problem. I'm going to say I equals 1. Excuse me. Here, I want to call this point 0. Oh, it's frozen. I'm sorry. We want to call this point 0. This is point 1. This is 2. This is 3, and so on and so forth. But RStudio, unlike other languages like, for example, Python, starts indexing at 1, not at 0. So the first point is 1, not 0. So I say, so we are going to assume that this is 0. we are going to solve a whole problem. But then when I ask RStudio, how many steps did it take? I'm going to subtract one from the I get. Do you understand what I'm saying? I'm not starting at I equals zero because there is no matrix zero, like matrix with index zero. It doesn't exist. Well, we can change that, but I'm saying let's play it this way. Here, I'm going to introduce something in programming other than the for loop. Here I cannot do for because I don't know when. Well, I can do for and then break if I reach a specific condition, but it might be better to use a while loop or a repeat until. I think while we haven't used the while, so that's a good place to start it. So I'm going to say while. I want to say while what? While the x coordinate of the point, oh my God, is between -10 and 10, and the y, so the x coordinate of the point, I'm sorry, is between -10 and 10, and the y coordinate as well to be between -10 and 10. So notice it's between, so instead of saying if x is greater than -10 and less than +10, and the y is greater, we can use the absolute value. And we can say while the absolute value of my mat of I and 1 is less than 10. No, I have to have absolute value between parentheses, okay? And so notice we use double ampersands. Or if we want or, we use double pipes, okay? And then I'm going to repeat what or the absolute value of my mat, because basically what I'm going to, here I created a matrix with 1,000 rows and 2 columns, right? Store the x coordinate in column 1 and the y in column 2. Okay, so my mat I is the replicates, number of replicates of the simulation replicates. And this is a counter, of course, you can call it whatever you want. And here we want to say while the x coordinate or the absolute value of the x coordinate is less than 10, meaning between -10 and 10, and that of the y, which is I and 2, is also less than 10. What do I do? Notice we have to open braces and close them. And here, all what I have to do is to say, well, the x, notice that first of all, I have I equals 1. But I want to refer, I'm going to say, take the previous point, add a uniformly distributed random deviate from that to the x and 1 to the y. So I have to say increment I first, right? Because if I leave it, I can leave it, but it won't show me 0 and 0, 0.0. I want to leave the 0 and 0 here. Let me show you what I mean. Let's run this. Notice when I run this, I start with the first value. Oh, I can't use NA. So let's make it 0. Let's make it 0. But it will start here, entering the values. So I can say step 0, which is row 1, is 0 and 0, which is the origin. And then I will move one by one. I'm glad I did that because I had in mind to make it zeros, and then I said, let's make it blank, and I didn't think about it. So here I'm going to say, so I'm going to assume that I equals 1 is the origin, even though in my matrix, I equals 1 would be the first step. And that's why I said at the end of the day, I'm going to subtract 1 from the answer. Again, if you didn't get that, I will explain it again. So here I'm going to say I equals I plus 1. And then, oops, sorry. And then I'm going to say my math of I and 1 equals my math of I minus 1 and 1, which was the previous point. Notice if I is 1, I'm going to say, oh, get me the point in the matrix where the index is 0, and it will give me an error. That's why I had to add 1 to begin with. Okay? So my math, the previous, and then add to that a random uniform run if just 1 point, but make it can move in any direction. So make that -1 to 1. Okay, so now it's going to give me an X component, and also I want it to give me a Y component. So I'm going to copy that and paste it, change the 1 into 2. That's all what I need instead of typing the whole thing. I'm done. That's it. Do you believe it? This is all what I want. It would going to add a uniformly distributed point between -1 and 1 until one of these two conditions is not satisfied. Notice I said and. Both of them have to be less than 10. If one is not, one stepped outside, I'm going to stop. So what do I do after that? I will say, well, remember we said you can use concatenation, and you say it took the particle, and then I'm going to leave it blank and say I minus 1, not I minus 1 steps to go out of bounds. Oh my God. Okay. It's my laptop is high, so I can type easily. Type of bound to go at, maybe at an X equals, and then I can format it. Remember, we used two ways to format thing. We can say, for example, format, and then between parentheses, I'm going to say X, which is my math of I and 1. And then I say I want it, say, in 4 digits, meaning 1 or 2 decimal, 1 or 2 integer, and 1 or 2 decimals, or 2 or 3, depending. Digits equals 4, for example, or 3, or whatever. Okay? And then I'm going to say, and a Y value of, and then I can say here, as print f, and then I enter the formatting I want. So 4.2f, for example, to be similar, and my math of I and 2. I hope we didn't do anything wrong. After that, I'm going to open the screen to plot. So remember, if you are using a Windows, you type Windows. If you are using a Mac, you say Quartz. And then you're going to plot. So I'm going to plot my math, everything in 1, not I and 1. I meaning it's just 1 point. But if I leave it blank, it's taking all the 100 or 200 steps that it took until the particle went outside the bounds. That's my X, and my Y would be my math of everything into. Okay. After that, we can say color equals whatever, green, for example. Oops. Um, I can say the X label is just X, the Y label is just Y. I can say, or maybe I have to add a comma, and I give the limits of X and Y. So X limit, I want just to show on the screen between -10 and 10. I don't want just a part of it. So I'm going to say X limit equals C, combining -10 and 10. Same thing for the Y. The Y limit is C, -10 and 10. At the end of the day, that's something else I want to show it to you. Suppose I want to show the borders of the part. I want to have the y's and the x's at -10 and 10. So we use that using, or we do that using a function called AB line. AB line, oops, line, no. AB line means I can draw a line with A and B, meaning, let me show you what I mean. Suppose I want to draw a line, suppose I have a regression and I want to draw a line along the points. I'm going to call, oops, I'm sorry. No, it's, I apologize for that. I told you it stuck like sometimes it freezes and it doesn't show, hopefully. Okay. So that would assume that I have a slope of A and y-intercept of B. Y equals AX plus B. So I can enter A equals, say, 1, if that's 45 degrees, and B equals 2, or whatever. Or this would be -8, for example. But that's not what I want. I want to draw a horizontal line here and a vertical line. Oh, sorry, at 10 and -10. So this is -10, this is 10, and for this is -10 and this is 10. I want to draw that to show where the particle was inside that. So we do that by saying H and V. H for horizontal, very simple. H equals combine -10 and 10, and the V, the vertical, is also C of -10 and 10. Let's see how many errors did we get, and then we correct those. Yeah, my math. Oh, percent. I used a dollar sign for some reason. I don't know how I did that, but that's a percent. Okay, let's see again. What else? Couldn't find function f sprint print f, not printf. Okay, that's what you get. Oh, why did it? Okay. Oh, okay. Something else. Something else is not right. We didn't show. Let me get the window again. Yeah, I did everything and I forgot to say, and the type equals L. I want line, not dots like it showed me. So hopefully this would work. Okay, let's see here. Okay, I can enlarge, and you can see that we stepped out at this point in the Y. The X was fine, but we started at the origin and we kept moving up and down, right and left, and then eventually it went out. So let's go back to R and see what happened. So when I enlarge that, it says that it took 159 steps to go out of bounds. The X at that point was -5.455, and the Y was -10.7. That's why I stepped out at the bottom, not right, left, or up. And that's basically it. So you see, it really didn't take long to, much of the writing was what I want to show on the screen. Notice we learn how to uh, save that into a file. I could have said file equals, and then I make append equals true, meaning it's not going to overwrite. And then I can also go to the figure, copy and paste it in that uh, thing. So all of that from line 17 up to 25, that was just formatting. But the actual programming, believe it or not, was these 4 lines. That's all. I just created a counter. I created an empty matrix. I said, let's run it for 4,000 times, but it really took me 4 lines, right? So it's not that bad. Maybe we're going to take this later and try to model something in queuing. You know, when you enter a store and there is, say, 1 or 2 servers, and you want to see how long it's going to take you to stay in the line or to complete your transaction. If we know how fast these or this or these tellers are taking, okay? And it would be something similar to that, except that instead of, yeah, so we'll be building something similar to that, okay? It's like the time it takes in the line, and then you add, say, service time and so on and so forth. So we can use something similar to that and model a completely different actual application or actual scenario in real life. And that's what we need to learn when we do simulation. Take uh, theoretical stuff, and we see how we can run simulation using a for loop, a while loop, a repeat until. We don't have do until in RStudio. It's repeat something until until an event occurs. Um, and I hope this wasn't that bad. As I said, it doesn't teach you something. It's not something interesting, but it is something that it's a tool that we can use to model different, more complex situations. I hope it wasn't that bad, and I wish you all the best. See you soon.